We will evaluate the given inverse cotangent function values using the reference triangles shown here below. Where each inverse cotangent function value is equal to an angle on the open interval from 0 to pi radians, which means in standard position, again the angle will be from 0 to pi radians, not including the two endpoints, which is this interval here. And since cotangent theta is equal to x divided by y on the coordinate plane, notice cotangent is positive in the first quadrant and negative in the second quadrant. To begin, we have inverse cotangent of -1, which is equal to the angle in this interval that has a cotangent function value of -1. Using the reference triangles, we begin by ignoring the negative sign for a moment and determine which angle has a cotangent function value of +1. Using right triangle trigonometry, cotangent theta is equal to the ratio of the adjacent side to the opposite side. Referring to the reference triangles, notice how the cotangent of 45 degrees, or pi divided by 4 radians, again is equal to the ratio of the adjacent side to the opposite side, which gives us 1 divided by 1, which is +1. And since we are looking for the angle that has a cotangent function value of -1, we are not looking for the angle of 45 degrees, or pi divided by 4 radians, but this is the reference angle that we will use in the second quadrant to determine the angle in this interval that does have a cotangent function value of -1. The next step is to sketch a reference angle of 45 degrees in the second quadrant, which means this is the terminal side of the angle we are looking for, again where the reference angle is 45 degrees, or pi divided by 4 radians. Let's go ahead and sketch the reference triangle. Because we are in the second quadrant where x is negative and y is positive, we would label the adjacent leg -1, the opposite leg 1, and the hypotenuse square root 2. Notice how this reference triangle does give us a cotangent function value of -1 divided by 1, which is -1. Which means the angle we are looking for in the open interval from 0 to pi radians has its initial side along the positive x-axis and the terminal side along this ray, and therefore the angle we are looking for in the interval that has a cotangent function value of -1 is 135 degrees, or 3/4 pi radians, which we can determine by taking 180 degrees and subtracting the reference angle of 45 degrees, or pi radians, and subtracting pi over 4, or 1/4 pi radians, and therefore inverse cotangent of -1 is equal to 135 degrees, or in radians, 3/4 pi radians. Next we have inverse cotangent of square root 3, which if it's helpful we could write square root 3 as a fraction with the denominator of 1. This is equal to inverse cotangent of square root 3 over 1. And now we go back to the reference triangles and determine which angle has a cotangent function value of square root 3 divided by 1. Looking at the 30, 60, 90 reference triangle, notice how the cotangent of 30 degrees, or pi divided by 6 radians, which again is equal to the ratio of the adjacent side to the opposite side, is square root 3 divided by 1, which is the given cotangent function value, and therefore the angle we are looking for is 30 degrees, or in radians, pi over 6, or 1/6 pi radians. So notice how when the given cotangent function value is positive, we can use the reference triangles as is, and we don't have to sketch the reference angle or the reference triangle. But let's go ahead and show the reference angle and triangle anyway on the coordinate plane, which, because the cotangent function value is positive, would be in the first quadrant. So let's sketch a reference angle of 30 degrees in the first quadrant, which means the terminal side would be here, where the reference angle again is 30 degrees, or pi divided by 6 radians. And now let's sketch the reference triangle. We are in the first quadrant where both x and y are positive, and therefore the opposite side is 1, the hypotenuse is 2, and the longer leg is positive square root 3. Again, notice how the ratio of the adjacent side to the opposite side is square root 3, and therefore the angle we are looking for has its initial side along the positive x-axis, terminal side along this ray, and notice how the angle is the same as the reference angle of 30 degrees, or in radians, pi over 6, or 1/6 pi radians. Next we have inverse cotangent of negative square root 3 divided by 3. Because of the square root 3, we should be able to recognize we will be using the 30, 60, 90 reference triangle, but to make it easier to recognize the angle we will use to evaluate this, it may be helpful to rationalize the numerator, so let's go ahead and show that. If we have negative square root 3 divided by 3, and want to rationalize the numerator, we multiply the numerator and denominator by the square root of 3, which gives us negative 3 divided by 3 square root of 3. 3 divided by 3 simplifies to 1, and therefore this simplifies to negative 1 divided by square root of 3. We can rewrite this as inverse cotangent of negative 1 divided by square root of 3. Ignoring the negative sign for a moment, going back to the reference triangles, notice how the cotangent of 60 degrees, or pi divided by 3 radians, is equal to the ratio of the adjacent side to the opposite side, which is 1 divided by square root of 3. And because we want the angle that has a cotangent function value of negative 1 divided by square root of 3, if the angle is not 60 degrees, or pi divided by 3 radians, but this is the reference angle we will use in the second quadrant to determine the angle we are looking for. So we now sketch a reference angle of 60 degrees, or pi divided by 3 radians in the second quadrant, and therefore the terminal side is here for the angle we are looking for, where this reference angle is, again, 60 degrees, or pi divided by 3 radians. Let's sketch the reference triangle. We're in the second quadrant where x is negative and y is positive. We'll label this leg negative 1, the hypotenuse 2, and this leg positive square root of 3. Again, notice how this reference triangle does give a cotangent function value of negative 1 divided by square root of 3, which means the angle we are looking for in the open interval from 0 to pi radians that has a cotangent function value of negative 1 divided by square root of 3 has its initial side along the positive x-axis, terminal side along this ray. Rotating counterclockwise, this is going to be 120 degrees, or 2/3 pi radians, which we can determine by taking 180 degrees and subtracting the reference angle of 60 degrees, or pi radians, and subtracting pi over 3, or 1/3 pi radians, which gives us the angle in degrees and radians. This is equal to 120 degrees, or in radians, 2/3 pi radians. And then finally we have inverse cotangent of 0. I wanted to include this one because we will not be able to use the reference triangle to evaluate this. We will have to use either the unit circle or our knowledge of the graph of the cotangent function. On the unit circle, cotangent theta is equal to x divided by y, which means to evaluate this using the unit circle, we need to find the point on the unit circle in this interval where x divided by y is equal to 0. X divided by y is equal to 0 at this point on the unit circle in the given interval where the x-coordinate is 0 and the y-coordinate is positive 1. Notice x divided by y is 0 divided by 1, which is 0. Which means the terminal side of the angle we are looking for that has a cotangent function value of 0 in this interval has the terminal side along the positive y-axis, the initial side along the positive x-axis, and therefore the angle is 90 degrees, or in radians, pi over 2, or 1/2 pi radians. Another way to evaluate this would be to take a look at the graph of the cotangent function and determine the angle in the open interval from 0 to pi radians that gives a cotangent function value of 0. So here is the graph of the cotangent function only on the open interval from 0 to pi radians. And notice how the cotangent function value is 0 at this point where the angle is pi over 2 radians, or 90 degrees. I hope you found this helpful.